Everyone, I'm McKay Blevingood, and today I'm going to walk you through the Physics 2212 Lab 1 on charged tapes. The goal of this lab is to understand the interactions between two electrically charged pieces of tape. We're going to do this through conducting a physical experiment and computationally simulate these interactions through the use of glow script to determine the charge of the tape and then to approximate how much excess charge or the deficient amount of charge on the piece of tape. Through the experiment, we discovered that the charge of the tape is 1.52 times 10 to the negative 8 coulombs, and that 9.48 times 10 to the 10 electrons are on the tape, meaning that there is a deficiency of electrons. Before we get into the lab, here are some important concepts and equations that we'll need to know. First, we have electric force, which is K Q squared over D squared. D is the distance between the two tapes, and Q is the charge of one tape. We're assuming the tapes have the same charge, which is why it's QB squared. We also have the electric force written in a different format, which is Q times the electric field, and then we have K constant, which is 9 times 10 to the 9th, and E constant, which is 1.6 times 10 to the negative 19th. So now let's get into the experimental portion of this lab. We have the initial conditions, which is the tape mass that was given to us. It's 2 times 10 to the negative 4th kilograms. The tape length was 20 centimeters, so 0.2 meters, and then 0.025 meters was the tape width. The specifications that we have, the system is tape B and the surroundings is tape A and earth. So the tape A and earth are both exerting forces on tape B. The assumptions that we're making during this lab include that air resistance is negligible. We're also treating that the long piece of tape as though it was a point charge. And all the charge is concentrated at the center of the long tape. And we're also assuming that each piece of tape has the same amount of charge that's evenly distributed along the length of the tape. Now we're getting into a little bit of an analysis. The distance between the two tapes was 0.0325 meters, and we positioned the tapes as pictured in the top right-hand corner of the screen. Both of the tapes had a positive charge, and this was determined because the tape was attracted to a negatively charged plastic pen. So the tapes were originally 0.03 meters apart, but due to the repulsive electric force, tape B moved up a distance of 0.0025 meters. This is because the tapes have like charges and therefore there's a repulsive electric force. The calculation results ended up being that the charge of tape B was 1.52 times 10 to the negative 8th. The number of electrons on tape B was 9.48 times 10 to the 10th, and there's a deficiency of electrons because the tape is positively charged. Now we are going to get into the computational portion of this lab. In the first part of the code, we calculated the charge of the tape. This was done by setting certain constants and initial values equal to the values measured within the lab. That's what the first few lines of code are. And then further down in the code, we have the calculation portion. So for this, I plugged in the equation for the electric force, and then from there I was able to rearrange variables and find Q, which is the charge of the tape. What we found was consistent with what was discovered in the lab. We are going to move on to the second part of the code. This is much more involved, but it's still somewhat simplistic. So throughout the code, there are lots of different equations. First, we have solving for the electric field, and then also solving for the electric field and the electric force between the two tapes, and the gravitational force between the two tapes. At the end of all of this, the code prints the magnitude of the electric force and the magnitude of the gravitational force. Again, all of this is just plugging in equations and rearranging variables, and some lines of code were used to visually represent the electric force and electric field in vector form through arrows. See here we have the arrow vectors showing the electric force and the gravitational force. These values were less consistent with what was actually discovered in the lab itself. This could be due to loss of charge when handling the tape. It could also be due to the assumptions that the tapes were point charges and additional forces from the surroundings that were not accounted for. The electrons had a positive charge and protons had a negative charge. The values would not change because the tapes would still repel each other due to having the same charge, and the interactions and forces between the two tapes would remain the same. It was important to handle the charged tapes as little as possible because charges can transfer to your hands. So if the charge transfers from the tape to your hands, then the electric force from the tape will be weaker due to the decrease in the Q value. Thank you so much.